In this lecture, we will learn some three-dimensional manipulating functions, such as three-dimensional move, rotation, mirror, array, and scale functions. Generally, most two-dimensional editing commands can also be applied for the 3D objects, such as erase, copy, chamfer, fillet. The settings of these commands are exactly the same to the two-dimensional design. However, in the three-dimensional environment, some functions are a little bit different. For example, we will have the rotate 3D for the rotations, mirror 3D for mirror, and 3D array for the array operations. We will also have the 3D align, 3D scale, and 3D movements. In the rest of this lecture, I will show you how to use these different commands under the 3D environment. Now let's see the fillet command. Actually, the two-dimensional fillet command can also be applied to smooth the edges of the 3D object, but different from the two-dimensional joinings. In the three-dimensional space, the fillet command will use the surface to smooth the edges of the two straight planes. Similarly, we can also use the chamfer command to modify the edges of the 3D objects. Different from the fillet command, the chamfer command will smooth the edges within a flat plane. Now let's see a simple example to apply the fillet and chamfer command. In this example, we will consider the box and we will apply the fillet command to the four edges, 1, 2, 3, and 4. And then we will apply the chamfer command to the top plane. So first, for the fillet command, just type fillet. And the first thing you need to do is specify the object you want to modify. So here we want to modify the box, and then choose the box. Then you have to define the radius for the fillet. Say the radius is 3 units. And then you have to specify the edges you want to modify. You also can use the chain or the loop commands to define multiple edges. Here we want to select 4 edges. So these 4 edges are all selected, and then click enter. You smooth all these 4 edges. And next, let's see the chamfer command to smooth the top plane. Type chamfer, and then specify the first line or define the plane you want to smooth. Here we want to smooth the top plane, so we have to choose the edge here. And this is the plane we already select. If you don't like it, you can choose next to find another plane. And then click the back. This is what we want to modify. Click OK. You have to specify the base chamfer distance. Say the distance is 1 unit, and then specify the second distance. Say it's also 1 unit. And then you have to define the edge. Actually, here we want to smooth all the loop, so we have to define the loop and choose this loop. Now click OK. You smooth the edges of the top plane. The first 3D manipulation function we will learn is a rotation, and the command for us to rotate a 3D object is rotate 3D. Actually, in two-dimensional joinings, we already learned one command, rotate, to rotate two-dimensional objects, and this command can help us to rotate the object around a point. While in three-dimensional space, we cannot rotate a 3D object around a point. Instead, we need to rotate the object around an axis. So for the rotate 3D command, we have to define the axis. And the most common method for us to define the axis is 2 points. So we will just use 2 points in the 3D space to identify the axis. Or we can rotate the object around the X, Y, or the Z axis. We can also specify the line on the current joining or a line segment on the polyline as the rotating axis. And we can also use the arc or the circle to define the rotation axis. If we choose arc or circle, then the lines that are perpendicular to the arc or the circle and crossing their centers will be used as the axis. In the next demonstration, I'm going to show you how to use the rotate 3D command to generate the chair here. To generate this chair, we should first change the view style to the 2D wireframe, and then we will use the box command to generate the base. You can specify the dimension by yourself, but we set the thickness as 0.5 units. And then we will call the box command again to generate the legs. Go to the box and specify the leg. Say the length of the leg is about 15 units. And then we can call the copy command to copy this leg to the other 3 corners. Now you see that it will generate base with 4 legs, but actually the leg is put upwards. We want to put the legs downwards, so we have to call the rotate 3D command and select all the base and the legs. And now we define the axis. We will use this edge as the axis. Specify the rotation angle as 180 degrees, so it will flip the base and the legs. And next step, we will generate the back. Go to the box command and define appropriate size for the back. The height is also set as 0.5. And then we want to rotate the back a little bit to generate the chair. Go to the rotate 3D command, select the back, and now define the intersection as the axis. Say the rotation angle is 85 degrees. And now you rotate the back upwards and complete the generation of the chair. Similar to two-dimensional joinings, in the three-dimensional space, we also have the mirror function to generate a copy about a 3D objects. The command is mirror 3D. Actually, in two-dimensional space, we are using the mirror command to make a copy about one two-dimensional object, and the mirror is set as a line. But in three-dimensional space, the mirror should be a realistic mirror, so it should be in the plane. Generally, we are using 3 points to identify the plane as the mirror. We can also use the existing XY plane, YZ plane, or XZ plane as the mirror. Or you can use your current viewport as the mirror. Another kind of object can be used as a mirror are the circles, arcs, or the two-dimensional polyline segments. All those objects can help us to generate a plane, and this plane will be used as the mirror in the mirror 3D command. Now let's see a simple example to generate a mirror copy about a chair that we generated in the previous example. First, let's call the mirror 3D command, and then select the source object. Now the default method is 3 points, so you can define any 3 points on the three-dimensional space to identify the plane. For example, if I'm choosing 3 points on this flat plane, then you can use this plane as the mirror. And now you have the option to decide whether you want to delete the source object. If you choose no, then you will keep the source object, which means we will keep the chair at this location. Click enter. It makes a mirror copy about the chair on the right side of this plane. The second method is a XY, YZ, or XZ plane. So still go to the mirror 3D and choose the source object. And then you can specify ZX plane. And now you need to identify one point on the ZX plane. We will keep the origin. And then you make a copy about the chair, which will apply the current YZ plane as the mirror. The last method is applying an existing object. Still, we apply this chair as the source object. And now you can go to the object, and then you can select the circle, arc, or the 3D polyline to identify the plane for the mirror. Here we have one circle placed on the XY plane. If we choose this one as the mirror, then you will use the XY lane as the mirror. And then you make a mirror copy above the chair, which is below the XY plane. In three-dimensional drawings, the scale command is a 3D scale and the move command is a 3D move. Even though these two commands are a little bit different from the scale and move command in the two-dimensional drawings, their settings are exactly the same. For the scale command, you can set up the scale factor to change the size of the 3D objects. For the move command, you can set the base point and displacement to change the location of the objects. Sometimes you can even use the scale and the move commands from the two-dimensional drawings to change the size and the location of the 3D objects. In three-dimensional space, the array functions will also be different. To generate three-dimensional arrays, we have to call the command 3D array. But different from the two-dimensional array command, and this command will only have the rectangular and the polar methods for us to generate the arrays. In the next demonstration, I will show you how to use these two options and how to use the polar array to complete the figure here. Actually, the setting of the three-dimensional array is much simpler than the two-dimensional arrays. First, let's go to see the rectangular three-dimensional arrays. Here we will call the command 3D array, and we will make an array copy about this box. So we have to select this box as the source object, and then you need to choose the method as the rectangular. Now you have to identify the number of the rows, say it's 3, number of the column 4, and number of levels 2. And next step, you need to identify the distance between the rows, 5 units, distance between columns, 5 units, and the distance between levels, 5 units. And now you complete the definition of the rectangular array for the box. If we go to the conceptual style, you can see the effect clearly. And here, remember that with the rectangular array, the rows is always associated with the y-axis, and the columns are always associated with the x-axis, and levels are always associated with the z-axis. So you cannot change the directions of the rows, columns, and levels. So that's the definition of the three-dimensional rectangular array. And now let's go to see the polar array. Here we want to make a polar array about this box around this cylinder. Go to the 3D array and specify the source object. Choose polar method. And now you have to define how many items you want to set for this array. If we want to set a 8 box, type 8 here. Next step, you have to specify the angle to fill. Say it's 240 degree. And next step, you can choose whether you want to rotate the box or not. Usually we will choose the rotate option. And now you need to specify the axis for the polar array. We will use the axis of this cylinder as the axis of the polar array. So that one gives you the definition of the polar array for this box around the axis of this cylinder. In this demonstration, I will show you how to draw the figures in the previous slides. First, we have to call the cylinder command to draw the larger cylinder here. You can specify the height as 10 units. And then we need to draw a smaller cylinder. Say the radius is 0.25 and the height is 4 units. And next step, you have to rotate this cylinder to make the cylinder aligned on the XY plane. So go to the Rotate 3D, choose the object, and then use the 2 points to identify the axis. Select the first quadrant point and the second quadrant, and then specify the rotation angle as 90 degrees. Now you rotate this cylinder at the XY plane. And next step, for the move command, choose this object, and then select the center here, move this object to the quadrant point of the base, and then call the 3D array. Choose this one as the source object. Select the polar method, identify number of the item as 8. The angle to fill is 360 degrees. Rotate the object. At last step, you have to specify the axis for the polar array. Choose the axis of this cylinder. And now you need to rotate the entire object. So go to the Rotate 3D. Choose all these objects. And then use the 2 points, the center of this base to the center of this base as the axis. And the rotation angle is set as -30 degrees. Now you get the figure in the previous slides. From the previous slides, we can know that the 3D array command can only allow us to generate a rectangular and polar array. It cannot help us to generate a path array. Actually, if we want to generate a 3D path array, you have to call the command array path, and this command can help us to generate a set of copies of all the 3D objects along a 3D line. In the next demonstration, I will show you one simple example about the implementation of the array path command. In this demonstration, I will show you how to use the array path command to generate a set of the styles around this axis and along this path. First, we will change the style to the 2D wireframe, and then we will call the array path command. Now the source object will be the box here. It will be used as the style in this figure. Choose this box. And then you have to select the path. We are using this curve as the path. And next step, you have to define the base point. So you need to identify the center of this plane as the base point. Now you can see that all these styles is associated with the curve. And next step, you have to check the methods. Right now the method is manual. It's better for you to change this one back to the divide so that you can identify the number of the styles you want to place along this curve. So for the item number, we would like to set the value as 21. And actually all the other settings are very similar to the array path in the two-dimensional space. Also, you have to make sure that the align items option is set as yes. And then you complete the generation of the styles around the cylinder. Now if you go to the conceptual style, you will see these styles clearly and it's aligned along this path and also around the cylinder. AutoCAD also provides another function for us to cut 3D objects so that we can see the components inside of the 3D objects. The command is a slice. With this command, we can use a plane to divide a 3D object into two separate parts. In the example here, we will use 1, 2, and 3 points to identify the plane and then cut this object into two parts. At the next step, you can decide which part you want to keep on your current drawing. In this demonstration, I will show you how to use the slice command to check the components inside of the object here. First, we have to call the command slice, and then we need to specify the object we want to operate. And next step, you have to define the slicing plan based on different methods. Actually, in this class, you just need to understand the 3 points method. For this method, we are using 3 points to define the plane in the three-dimensional space. In the example here, we are using the 3 corners of this box to identify the plane. And at the last step, you have to decide which part of this object you want to keep on your current drawing. You can also keep both sides on the drawing. For the example here, we want to check the inside of this box, so we want to keep the back side. Select any points on the back, and now you will have the back half of the object left on the drawing. And this is what the inside of the box looks like. The last command we'll learn in this lecture is a section. This command can help us to find out the cross-section of 3D objects at any location you want to check. Here I will show you how to use the section command to find out the cross-section of this object. Right now, as you cannot see the other components inside of this object, so you cannot draw the cross-section of this object correctly by your hand. So we need to call the section command. At first, you have to define the object you want to check. And then you need to specify the section plane. This command actually defines many methods for us to specify the section plane. In this class, you just need to understand the 3 points method. This method is sufficient for us to find out the location of the cross-section. For the example here, I will use the endpoint of the 3 edges. Once you specify the plane, the cross-section is generated. And then let's move the cross-section outside of the object to see the shape of the cross-section. And now set a displacement. This is the cross-section of this object. And if we go to the top view of the object, you will see 2 holes here, and that will be the 2 gaps in the cross-section. This is the end of the first part about the 3-dimensional drawings. In the lecture today, we'll learn some 3D manipulation functions. And those functions are very important for us to draw some complex 3-dimensional objects. So after class, you have to spend some time to get familiar with the commands introduced in this lecture. You can go through the instruction in this video and work on the examples by yourself. And also you can get more practice from the in-class and the homework assignments.